Hey everyone, in this video we're going to look at preparatory support material for Math 155, week number 8. Specifically, we're going to look at how to solve linear equations. Your Math 155 instructor will have explained what a linear equation's purpose is. And we're going to look at using the solution of an equation to find the value of a given expression. A long-winded way to say we're going to solve for some unknown. Then we're going to plug that unknown back into the equation and see what the result is. Okay? All righty. So without any further ado, let's go ahead and get this show on the road. So the process of solving linear equations is going to look very similar. The mathematics is the exact same, if you will, to what we've done in previous weeks where we were solving for some unknown. We're going to follow the exact same rules. We're going to isolate our variable, mathematical way of saying getting our variable by itself on one side of our equal sign. And we're going to follow some simple rules to do so. The rules being that common practice-wise anyway, we like to have our variable to the left side of the equal. Does it matter? No. Your instructor may have a preference. There may be a preference when you're entering solutions into, say, a computer program. It may prefer that you put the variable to one side of equal than the other. There is simply, though, a common practice that we leave it to the left side of equal. Does it matter? At the end of the day, no. But we're going to stick to that for the most part, I believe, in all these examples. We're going to stick to that common practice of leaving it to the left of equal. Meaning, therefore, we're going to remove all the other terms. Remember, in a mathematical sentence, we have variable terms, we have operators, those things we're doing to our terms. Adding, subtracting, multiplying, dividing, we're operating on a term. We have a variable term, we have a constant term, we have a constant term. So what we're going to do is we're going to create a situation where our variable terms are to the left of the equal sign and our constant terms are to the right. And the other rule, the other thing we have to recall is that to eliminate, to remove, if you will, or to rearrange more correctly a constant term from one side of an equation to another, it has an equal sign, it's called an equation. No equal sign, it's called an expression. To move it from one side to the other, we always do the opposite. So here with this first equation, x plus 71 equals 90. To solve this equation, we're simply going to remove the term plus 71. Our signs always go with our terms, okay, by doing the opposite. And what's the opposite of adding? It's subtracting, of course. And we recall, hopefully, that our equal sign means balance. You know, we think of it like a scale. Currently, it's balanced. What's on one side of our equal sign is equal to the other. Therefore, to keep it balanced, anything we do on one side of our equation, we have to do on the other. So on the left side, 71 minus 71 have canceled each other out. We're simply left with the value x. And here, we're simply going to go 90 minus 71. And we're going to arrive at, of course, 19. So our value here of x is 19. Now, your instructor may have gone into the reality of that when we're talking about linear equations, as a rule, we're talking about y and x axes. And we're talking about plotting these values. And to have values to plot, we need an x value, we need a y value. Here we found the x value. What is the y value? They may go into the reality that it can be anything you want it to be that will fit on the graph. You know, the y value may be. Basically, this is telling us to go over 19. Going this direction is positive. There in the middle is called our origin. That's 0.00. Going this way on the x-axis is negative. Going up is positive. Going down is negative. We always start at the origin. This is telling us to go 19 units this way. This is telling us to go up none on the y-axis. So that would plot somewhere like that. Again, I'm not too certain how much detail your 155 instructors are going into. So we're just going to focus on our ability to solve these linear equations. What they're having you do with those, that's up to them. Okay? All right, so let's look at the second example here. And this is the second example. We have the value, we have the term. This is a variable term, 2 times x, operator plus variable term, 7 times x equals 90. Okay? So variable term, operator, variable term, technically an operator, and a constant term. We may notice here that we have, two terms that have the same variable to the same power. It's implied each of those is to the first power. In that case, we can combine these. You have 2x's. I give you 7 more x's. You have 9x's. So that's the first thing you want to do when you're solving linear equations. You want to combine like terms, things that are entirely alike, you can combine. They must have the same variable to the same power. You can't combine x's with y's. You couldn't combine if this was x to the first and that was x to the second. You could not combine those because those are not like terms. They have to be entirely alike, not partially, but entirely. Okay, so again, we have the same situation where we have a variable term here. We're trying to isolate our variable, in this case, again, x. So what are we going to do? Well, we always do the opposite. This is 9 times x. The opposite of times is division. Now, another name, your Math 155 instructor may have gone into this. I think we've mentioned it in past videos as well. That another name for the value in front of the variable is the coefficient. So what we're also doing here, you may hear it talked about this way. We know our fraction bar means divide. Okay, we're basically dividing by the coefficient. And again, equal means balance, so we're going to do it on both sides. 9 divided by 9 technically gives us 1, but we know 1x is redundant. We just say x. Top number divided by bottom, of course we know that. Okay, 90 divided by 9 is 10. So in this case, we've solved our linear. We found that the value of x is 10. What is y? Your 155 instructor will talk more about that if they need you to know that for this part of the course. Okay. All righty, let's do a couple more. So here we're going to solve these two. We have the terms 15x minus 21 is equal to 2x plus 18. So we have a variable term, operator of subtraction. We have a constant term, technically an operator, equal is. We have a variable term, we have an operator, we have a constant term. So in this case, we notice we have variable terms and constant terms on both sides of our equal sign. So which way are we going to solve this? Are we going to move the 15x over to the right side? Because it really doesn't matter which side that we have the variable term on. It's just common practice to have it to the left. Or are we going to move this one to the left? Conversely, are we going to move this constant term to the right? Or are we going to move this constant term to the left? What are we going to do? Well, in a situation like this, if there is no preference by your instructor, you probably want to move it to the side, and we're talking about the variable terms, okay? Even though traditionally, according to the addition principle, we deal with the constant terms first, we make the decision which side to move to those. We're going to back up a step, and we're going to examine these variable terms. Because as a rule, we want to move the variable terms to the side that are going to leave us with positive variable terms. Okay, does it matter if we have a negative variable term? Yes, we don't like them as a rule, and there's a simple way. I think we have that coming up in another example of eliminating the negative sign, if you will, from a variable. But as a rule, we want to keep things simple on ourselves. If we're not told which side our variable needs to be on, common practice left, but if we're not told, let's examine this situation here real quick. We know this is a positive 15x, so to get rid of that, I'd have to go minus 15x. Well, that would give me 2x minus 15x. That would give me a negative 13x. Okay, not a big deal. But if we do it this way, we can make that this is a positive 2x. To eliminate that, we could go minus 2x. We pull that over, we end up with a positive number. So maybe that's something you want to look into. You know, it's not a real issue either way, but I'm going to go ahead and make the decision to keep my variable terms to the left and my constant terms to the right. So according to something called the addition principle, when we've got variable terms and constant terms, we deal with constant terms first. Does it really matter? No, but it's a good habit to follow a standard set of practices, standard set of rules, if you will, when it comes to operating on a problem. It's just simply something easy to remember. It's something easy to follow always. And then we'll do something called the multiplication principle. Basically tells us, okay, after we're done with the constant terms, deal with the variable terms. So in this case, we're going to go ahead and move our variable or constant terms to the right, our variable terms to the left. So to eliminate minus 21, we'll do the opposite, which is plus 21. Again, we know, but it needs to be reminded to us sometimes. We're creatures of habit. I can talk today. We do the same on the right side of the equation. So we go plus 21 here. Those will eliminate each other. We're left with 15 times x is equal to 2 times x. And then what do we have here? 8 plus 1 is 9. 1 plus 2 is 3. Okay, so there we are. We've done that. So now we've made the decision to keep our variable terms to the left. So we're going to pull this whole term out. We're going to pull the whole term 2x out. That's plus, so we're going to go minus 2x. Again, that equal means balance. Cancels itself out. Let's take it up to the right here. Okay, so 15 x's, you take away 2 of those x's, you have 13 x's. That has canceled, equals 39. Okay, so by combining, by moving things to one side of the equal sign or the other, we've gotten our equation down to this. 13 times x equals 39. We're trying to determine the value of x. So we're going to eliminate that coefficient. We're going to divide that coefficient out on both sides because equal means balance. We simply say those eliminate each other. They cancel each other out. Here we know our fraction bar means divide. We know it's top number divided by bottom, always and forever. 39 divided by 13 would be 3. So we've solved for x, and if your instructor wants you to go on further from that, they'll talk about the fact that y can be any value you'd like it to be, perhaps. All right, let's move on to this last one. This last one looks a little bit more complicated because we have grouping symbols, but it really isn't. You know, we have this value here, and generally that's what we say. Anything inside of a grouping symbol, parentheses, brackets, braces, absolute value bars, we call a value. We have the value 3 times x minus 25, and then we're going to add whatever that is to the value 11 times x minus 39, and we're saying all of that is equal to 90. So if we remember back to our order of operations, please excuse my dear Aunt Sally, she tells us that the first thing we need to do is do the math inside of the grouping symbols if we can, but here we can't because we have a variable term and a constant term. We can only do math or combine, if you will, like terms, okay? And the same thing here. But we need to get rid of our grouping symbols. So then we fall back on that property of distribution. Distribution says do what? It says take the value outside of the parentheses and multiply it times everything in the parentheses. Oftentimes it's called the property of multiplication over addition. Okay, but here in this case there's no value. Well, this is the case where we can imply there's a 1 there. Okay, because remember, multiplying something times 1 doesn't change its value. So we can go 1 times 3x, which is just 3x. We could go 1 times minus 25, which is minus 25. Remember, this is a positive 1. That's a positive 3x. When we're multiplying with signed numbers and the signs are the same, the answer is positive. So positive 1 times positive 3 gives us positive 3x. When we're multiplying with signed numbers, and you hear that term signed numbers, you're literally talking about pluses or minus. Plus or minus signs. If we go plus 1 times negative 25, when the signs are different, your answer is negative. So that's what that becomes. Here we're going to go plus 1 times positive 11x. That's going to give us plus 11x. So we did that, and now we're going to do this. Positive 1 times minus 35. Our signs are different, so minus 39 equals 90. So simply by distributing that 1 to each of these values in our parentheses and our grouping symbols, we've eliminated the grouping symbols. Now in this case, we're going to go and look at what we have and realize, oh, by the way, we have some like terms. We can go ahead and combine that. You have 3x's over here plus 11 more x's over there. You have 14x. And oh, by the way, we have the same thing here. We're at minus 25 here and we're minus 39 here. Okay, so what does that become? Well, is that a positive number? Is that a negative number? Well, remember when we're adding or subtracting with signed numbers, okay? Think of a number line. A number line is a great thing to think about, okay, when you're doing this. Let me pull this up on the screen so you can see it, okay? You know, we know that 0 would be there. We know to the right of 0 are positive numbers. We know to the left is negative. Well, here we're at minus 25, if you will, and then we're going to go minus another 39. So it literally what we're doing here is we're adding these numbers. Let me double check that. I think I hit a wrong number. 25 plus 39 is 64. All right, why is it not wanting to work? I think my fingers are not operating. 25 plus 39. There we go, 64. So we'd end up over here at minus 64. So we combine these two like terms. We have minus 64 equals 90. Okay, remember, anytime you can combine like terms, you do want to do so. Okay, and remember, like terms, a constant term can always go with another constant term, be it positive or negative. You know, they just happen to both be negative here. Variable terms can only go with other variable terms if they have the same variable to the same power. Okay, they have to be the same variable to the same power. So x's can only go with x's of the same power. Y's can only go with y's, z's, etc. You see the point, hopefully. So here, we've got this equation. We're going to try to figure out what x is. We'll just make the decision, go ahead and leave x on the left side of our problem, on the left side of our equation. So we're going to use that addition principle. We're going to eliminate the 64. We'll always do the opposite. We do it on both sides because we know equal means balance. So over here now we're left with 14x. Those two have canceled each other out. 0 plus 4 is of course 4. 9 plus 6 is 15. Okay, and again, lastly, we're left with 14x. Okay, 14, the value in front of our variable is called the coefficient. So we're going to do the opposite of what's going on to eliminate it. That's 14 times x. The opposite is division. Of course, equal means balance, so we divide by 14 on that side. Top number divided by bottom, we end up with 1x, or simply x. Over here, we know our fraction bar means divide. So it's always, again, we remind ourselves, it's always top value divided by bottom. So in our calculator, we'll put in 154 first, divided by 14, and we arrive at a solution of x of 11. Okay. All righty, let's move on. Now we're going to look at the second set of problems here in this video for week 8. We're going to solve each equation first, if you will, in order to evaluate the given expression. So long story short, we're going to figure out what x is, and then we're going to plug x into our expression here. So we're going to determine, the solution to this problem once we know what x is. That's the long and short of it. That's what we're doing here. The math language sometimes itself is the problem. Okay, find the value of 5x minus 2. Well, what does that mean? Well, it means solve this problem, figure out what x is, insert it here, do the math. That's all it means. Okay. So here we have our linear equation. 90 minus x is equal to 54. We're going to solve for x. Now here we notice we have a negative x. Okay, you can imply that there's a 1. Well, we'll do that in a minute. Let's just go ahead and follow our same MO, or modus operandi, mode of operation, if you will, in lay terms. Let's go ahead and leave our variable to the left, and so let's eliminate our constant terms. Well, here that's a plus. Okay, so we'll go minus. We do it on both sides. Okay, we're left with minus x is equal to, well, what does that equal to? Well, when we're adding or subtracting numbers with different signs, remember we have 3 rules. Okay, step 1 says ignore your signs. We don't see a plus or a minus, they're neutral. Step 2 says do what? It says subtract the smaller number from larger numbers. So we'll go 90 minus 54. We arrive at 36. So 36 is our answer. But is it positive or negative? Well, step 3 is where we determine that. And that's where we would go back to our original values here. We would look at those numbers, and we can imagine perhaps in our mind those numbers being on a number line. Well, which number is further from 0? Well, of course 90 is. What's its sign? Minus. So the answer is minus 36. Okay? Are we done? The answer is, well, we've got the variable by itself, right? X is on one side of the equal sign, common practice left side. We've got our constant value on the right side. So is the answer minus 36? Well, there's an issue. The issue is we don't like that negative sign. Okay? We don't like negative variables. So how do we eliminate that? Well, we simply divide the coefficient out. Remember, the number in front of a variable is called the coefficient. And you go, but wait, there's no number. Well, yeah, there kind of is. It's implied. How many x's do we have there? We have 1. Okay? And your sign, plus or minus, always goes with that number in front of the variable, which is called the coefficient. So technically, we have a coefficient of negative 1. Okay? So to eliminate that negative 1, because we want the variable by itself, okay, right now it's tied up with a negative 1, what do? Well, we do the opposite. This is negative 1 times x, so we divide by the negative 1. Remember, the sign, plus or minus, always goes with the coefficient. So we divide by it on that side. Those eliminate each other, so just leave us with x, okay? And then over here, of course, we know it's always top number divided by bottom. Fraction bar means divide. And remember, when we're multiplying or dividing with signed numbers, if our signs are the same, the answer is positive. Well, our signs are the same here, so x is equal to 36. So we're almost home. We know that x is 36, so we're going to insert it there. So basically, what do we do? Well, now we have the situation where we have 5 times 36 minus 2, and that's going to give us our final solution. So we'll go 5 times 36, which is 180, minus 2, which leaves us with 178. Okay, our expression evaluates to be 178. That's all you're being asked to do here, okay? If x, basically what we're being told, if x is a certain number, figure out what that number is. Well, we did. We did the math. We solved our linear. We arrived at the fact that x is equal to 36. Well, if that is the case, find the value of 5 times x minus 2. Well, if x is 36, we insert it. 5 times 36 is 180 minus 2, 178. All righty. Let's do some more. I think we have about 3 or 4 more of these. Solve each equation in order to evaluate the given expressions. Okay, or expression, as the case may be. If 5 times x minus 7 plus 3 times x minus 39 is equal to 90, find the value of 5 times x minus 7. Okay, so basically we're going to solve this whole linear equation to figure out the value of that piece of it. That's what we're going to do. So again, we have grouping symbols here. You know, parentheses, brackets, curly braces, absolute value bars are grouping symbols that tell us to do the math inside of those first, if you will. But in this case, we can't because we have what? We have variable terms, we have constant terms, and we can only do the math with like terms. Variable terms go with other like variable terms, constant terms go with other constant terms. But again, we need to eliminate what? The grouping symbol. So we fall back on the distributive property. We take the value outside the parentheses, multiply it times everything in the parentheses, and when there is no value, we can imply there's a 1. Okay, so then we'll multiply each of these times 1. 1 times 5x, 5x, signs are the same, so it stays positive. Positive 1 times negative 7, signs are different, so it stays negative. Plus 1 times 3x is 3x. 1 positive times negative 39 is negative 39 equals 90. We're going to take and combine like terms. You have 5x's, you have 3x's, so we end up with 8x's. You have minus 7 and minus 39. Think of this as a number line. You're at minus 7. You go further left of 39. You're at minus 46 equals 90. Okay? So at this point, we're to a linear equation that we recognize. So we're going to choose to leave our variable to the left. So let's eliminate this constant term by doing the opposite. Equal being balanced. We're going to do it on both sides. Cancels itself out. We're left with 8 times x equals, well, let's see, what is this? 0 plus 6 is 6. 9 plus 4 is 13. We want our variable by itself, so at this point we're going to divide our coefficient. Remembering our sign goes with our coefficient on both sides. We're left with the final solution. X is equal to, let's see here, 136 divided by 8 is equal to 17. Okay, so our value for x is 17, but we're not done. We're being asked to evaluate this expression here. So we've got the expression 5 times x minus 7. Well, what is x? Well, we now know that x is equal to 17. So we're going to insert 17 for x. 5 times 17 minus 7. And if we do that math, 5 times 17, we arrive at 85. Okay, and then minus 7, 85 minus 7, we arrive at a final solution of 78. So our expression evaluates to be 78. Okay, so we found a solution to a problem so we could solve another problem. That's another way of saying what we're doing here. Okay, that's all there is. The math is the same math you've been doing for several weeks. It's just the language making it sound difficult. It is not difficult at all. Okay, so why do we do this? Well, remember, math is a linear process. This is the stage of where we're crawling before we walk, well before we run, well before we think about doing marathons. This is just the fundamentals. This is just the dance steps, if you will. I haven't mentioned it that way in a long time. That's really all this is. This is just learning some dance steps so that later on we can take those dance steps and win the dancing contest, if you will. All righty. Couple more here. This one tells us if the value minus 4x plus 83 added to the value, I don't know what that is supposed to be. Let me pull out my sheet. I just realized that's a typo there. Let's see here. That should be a 9. I don't know where that came from. I should have caught that, but I did not proofread it that well. Okay, there we go. So that makes it right. Anyway, plus the value 9 times x minus 53 is equal to 90. We want to then find the value of minus 4x plus 83 and 9x minus 53. So we're going to solve this linear equation up here, determine the value of x, and then we're going to insert x back into each value to find the solution, okay, for each part totaling to be 90. All right, again, we have the same situation where we have the grouping symbols. We can't do the math inside the grouping symbols, so we're going to fall back on the distributive property. Here we don't have a value outside, so we'll insert the 1. Positive 1 times negative 4x gives us negative 4x. Positive 1 times positive 83 gives us positive 83. Positive 1 times 9x gives us plus 9x. Positive 1 times negative 53, signs are different, gives us negative 53, equals 90. Again, as before, we have some like terms, so we want to combine our like terms first. We have the variable terms minus 4x plus 9x. Another way of looking at this is you have 9x's, you take away 4x's, you have what? You have 5x's remaining. And in here we have what? We have the constant terms plus 83 and minus 53. Remember, when we're adding or subtracting numbers with different signs, if you will, a little cheap process is to ignore your signs. Just see, if you will, neutral values. Step 2 says subtract the smaller from larger. 83 minus 53 is 30. We go back to these original values. Imagine them being on a number line, which is further from 0. Well, of course, 83 is. What's its sign? It's plus 83, positive, so this is plus 30. So we combine these, we get 5x, we combine these, we get plus 30, and we're saying that's equal to 90. Okay, and we're almost home. We know we want our variable term to the left of the equal sign, common practice-wise anyway. We'll go minus 30. We always do the opposite. We do it on both sides. Eliminates itself. We have 5 times x is equal to 90 minus 30 is 60. Again, we're trying to do what? We're trying to find the value of x, so we're going to divide that coefficient 5 out on both sides because equal means balance. And then we're left with, finally, x is equal to 12. X is equal to 12. Okay, 60 divided by 5 is 12. So then what are we going to do? Are we done yet? No, we're going to go back to each of these expressions and we're going to plug in the value of, and we'll do this one over on the left side and we'll do this one on the right side. So we're going to go over here and we're going to go minus 4x plus 83, knowing that x is equal to 12. So this will be minus 4 times 12 plus 83. Well, 4 times 12 is 48, of course. 4 times 12 is 48. But remember, we got to look at our signs. This is negative, that's positive. When we're multiplying or dividing with signed numbers and the signs are different, the answer is negative. Okay, so plus 83. Again, we have the same situation as before. We're adding or subtracting numbers with different signs, so we can ignore the signs in step 1. Step 2, we'll subtract the smaller number from larger numbers, so 83 minus, 48. Okay, gives us 35. And then in step 3, we determine the value of that, the sign of that. Is it positive or negative? We go back to these original numbers, which is further from 0. Of course, 83 is. What's its sign? Positive, so it's positive 35. So we have basically we have found the value, the solution to this problem. Okay, we've plugged in 12. 12 was our solution to the linear equation. We've inserted it into this expression. 4 times 12 give us negative 48 plus that. So our solution to this problem is 35. So basically we're saying that all of this is 35 plus, well, let's do this one over here. Let's do this one over here on the right side. Let's try purple. We'll do it right here. So we've got 9 times x minus 53. Okay. Well, we know that x is 12, so we've solved for that. So we know it's 12. Okay, so we know it's 12. So let's plug this value in. So 9 times 12 minus 53. Well, what's 9 times 12? Let's see, 9 times 10 is 90. 9 times 2 is 18. So 108 minus 53. What does that give us? Let's see here. 9 times 12 equals minus 53 equals, that gives us 55. So we found the solution for this value over here being 55. Okay, by inserting our value of x into our original equation, we have found that. And then we can double check our math. Okay, we can go 35 plus 55, and that does indeed equal 90. Okay. One more. That's a lot, but that's okay. This is some of that stuff that needs more practice. This is one of those things, the more you see it, the more comfortable you become with it, and you get good at it by doing it. The more you do it, the better you are, realizing that in most cases, the first few times you're going to be wrong, and that's okay, that's expected, that's normal, it's not you. You got to do the math to do the math. So here we're going to look at these values, 7 times x minus 98 plus the value 5x minus 46 equals 180. So we're going to solve that linear equation. And then we're going to go back and we're going to find the value of each of those expressions in that linear equation. So we're going to do the same thing we did before. Let's try to keep it a little bit neater. Here we'll just do it up top here. We know that we're going to distribute a 1 to both. 1 times 7x is 7x. 1 times minus 98 is minus 98. Plus the value, 1 times 5x is 5x. 1 times positive times negative is minus 46. Equals 180. So in step 1, we've eliminated our grouping symbols. Now we're going to combine our like terms. 7x plus 5x gives us 12x. Minus 98 minus 46. Well, again, we're what? Think of your number line. You're at minus 98, okay? And then you go further 46 to the left. So you would be at minus 144. Minus 144 equals 180. Okay, then we're going to, as we've done in every one of these before, decide to keep our variable term to the left of the equal, common practice. So here we're going to eliminate our constant term first. We always do the opposite. Equal means balance. We do it on both sides. Cancels. We're left with 12 times x is equal to, let's see here, 180 minus 144 gives us 36. And then if we do the division, we always do the opposite. That's 12 times x. We divide by our coefficient. 12 is our coefficient on both sides. We're left with the solution to x of being, again, top number divided by bottom. 36 divided by 12 is 3. So x, the value for x is 3. We're now going to go back to our problem, and we're going to insert 3 into each expression. So we have the expression 7x minus 98. And over here we have the expression 5x minus 46. And I'll slide the page around so we can see it more clearly. So we know that x is 3, so we're going to go 7 times 3 minus 98, solve for that. Over here we're going to go 5 times 3 minus 46 and solve for that. Okay. Alrighty. Let's see here. Did I insert the right values? I did insert the right values. Okay. So let's solve this, and something's looking weird. Let me go back and check the original problem real quick. Minus 7x minus 98, 5x minus 4. Yep, that's what it has. All right. Minus 48. Yep. Okay. It just looked weird to me. Could be I'm just getting old and twitchy. 7 times 3 is 21 minus 98. Okay. And then we have what over here? We have 5 times 3 is 15 minus 46. Okay, we're adding numbers with different signs in both cases. So what are we going to do? Well, step 1 says ignore your signs. Step 2 says do what? Subtract the smaller number from the larger number. So we're going to go 98, losing my voice, sorry, minus 21 is equal to 77. Is that positive or negative? Well, let's see. We go back to the original values. Which of those two numbers would be further from 0? Well, of course, the 98 is. What's its sign? Minus. So it's minus 77. There's our solution to one of the expressions. Okay, so we're saying that this right here, this expression right here, is equal to minus 77. And we're going to do the math over here on this side. All right, so we're adding numbers with different signs again. So step 1 is what? Ignore our signs. Step 2 says subtract a smaller number from larger number. So 46 minus 15. We arrive at 31. 31 is our solution. Is it positive or negative? We go back to these original values, which is further from 0. Well, of course, the 46 is. What's its sign? Minus. So minus 31. So we found the other value. So this expression here, okay, has solved to be minus 77. Okay, minus 77. All right. Oh, I'm sorry. Something just looks weird. Something looks weird. We solved for x. X was 3. 7 times 3 minus 21 is minus 77. That's right. Plus 5 times x is... Okay, something just looks weird. 7 times x minus 98. I'm sorry, folks. I should have checked this problem beforehand. It just looks weird to me here. I'm just double checking. This is what you do sometimes. I do this for a living, and I do this sometimes. Okay, 5 times x. Okay, we distributed. We got rid of our values. None of the signs changed. Let me double check the original problem again. Make sure I don't have a sign in the wrong place. I do not. I copied it correctly. Okay, so we did the math here. 7x plus that gives us 5x, minus 98 minus 46 gives us that. We add that on both sides. We get 144. I see the problem right now. Okay, I see the problem right now. This right here, I subtracted them. Okay, yeah, I should have been adding them. So let's do that whole problem. And this is good this happens. Oh, by the way, here's what was going to happen. Here's what was going to happen. We found the solution to this problem was minus 77. Plus, we found the solution to that problem, minus 31. Okay, equals 180. Minus 77 plus 31 is minus 108. Okay, how could a minus 108 equals 180? It cannot. That would have been the solution we would have arrived at. Okay. So that's just not the case. So that right there tells us that our solution is incorrect. And this will happen. This is a happy accident because this is a chance to review the most common errors there are, if you will. When you know the math, and we've done 5 or 6 of these problems correctly, and all of a sudden we had an error in this one, does it mean the math is broken? No, it doesn't. The most common issue is the mistake I made here, okay? I subtracted those numbers. Why did I subtract those numbers? Because I'm a human being. I made an error, okay? In my mind, I saw that we were subtracting those. So let's go back and solve this problem knowing what we know. The fact is, let's start over right here, okay? So we know 7 times x minus 98 plus 5x minus 46 equals 180. The most common error there is the error I just made, and that is arithmetic. Okay, that is the most common error. Go back and check your arithmetic. All right, so 7x and 5x, we do know it's 12x. And if it's not arithmetic and you know that you know what you're doing, the most common error after that is a typo. Especially now that we use technology, it's real easy to hit a number 4 instead of a number 5, etc. Okay, so here we've got minus 98 minus 46. So let's see, what is that? 98 plus 46 is, again, minus 144. equals 180. We were good to this point. It's this point that the wheels fell off the wagon, if you will. We're going to go plus 144 plus 144. We're going to add this time, as we should have done in the first case. So we have 180 plus 144. We have 324 instead of 30-something. Okay. Now what are we going to do? We're going to do the same math. It's the same operation. We're going to divide that coefficient out on both sides so we can isolate our variable of x. 324 divided by 12 is 27 instead of 3. We were a factor of 9 times too small. So again, we had the original expressions that we're going to solve for. We have 7x. Let me copy them here real quick. Minus 98. And we have 5x minus 46. So we're going to go back and solve those, insert those into our equation, and see if it does indeed equal 180. Because we're saying all of this hot mess is equal to 180. So here we're going to go. We know that x is 27 correctly now. 7 times 27 minus 98. See, I intuitively knew I had made a mistake well back in the problem. You saw me pausing a good bit. I was like, where's that mistake? I didn't see it. But I knew I had made one. And that's a common error to make. And it's a good teaching tool. I need to do this on purpose more often, I guess. This was not on purpose. This was just human error. To point out the reality that even when you know what you're doing, you can still make mistakes. And usually the mistake is in arithmetic. All right. So 7 times 27 is 189 minus 98 minus 98. So the solution to the left side is 91. We're going to add that to the value over here, and hopefully that will equal 180. And if it does, we're done. All right, so 5 times 27, because we knew x was 27. 5 times 27 is 135 minus 46. So minus 46 equals 89. So 91 plus 89. 91 plus 89 does indeed equal 180. So 180 equals 180. We have found the solution. Okay, folks, this is a very good example. It's not a mistake. Every mistake is a learning event, and for you folks, this is a huge learning event. Okay, you know, if we had followed my logic, and I noticed that the wheels were falling off the wagon when I got down to here, I knew this was going to be a negative number. Okay, I knew that, you know, 15 minus 46 was going to be a negative number. How can two negative numbers equal, adding together anyway, equal positive? They can't. So that's where I recognized the wheel had fallen off the wagon. I just didn't see where. So then you notice what I did. I went back and I started checking my math. Did I have the right problem? Yes, I did. I went back to the original worksheet that I got these from and checked my numbers. Yes, I do have the correct numbers. So there were no typos there. Okay, then I did the math. Okay, well, we distributed, we got the numbers, 7x, 5x gave us 12x, that was still okay. Minus 98, minus 46 gave us minus 144, that was still okay. Add 44, add 44. Well, 180 plus 144 does not give us 36. So that's where the wheels fell off the wagon. Instead of adding like I should have, I actually subtracted. Okay, that's a very common error. Fact is, that's likely to be the most common error that each of you will make when you make mistakes with these types of problems, because those signs do change, and we sometimes forget to change them. So that's the first place you always do. First place you always look, if you will. Always go to see if there's a problem. Check your arithmetic. Make sure the signs didn't change on you. Okay, that's normally what it is. Once we did the correct arithmetic, you know, everything fell in place. All right, folks, that is it for, what is this, week number 8. Thanks.